Thank you for being so welcoming. This is my first time at this meetup, and this is just a very warm room. So thank you for having me here and making me feel part of it already. I'm Ben. I am an engineer. I've been in software for 25 years or so, doing all kinds of things. I'm an engineering manager these days, but I'm also a woodworker and basically tinkerer of all kinds, digital, physical things. Love to do things like this, which is my Kilopixel. And before I get started, we have a progress bar. Let me just SSH into the server here, change the mode, because my SSH session died, and get this thing going. There it is in Kilopixel. All right, I have given myself approximately 28 minutes for this progress bar to complete. We'll see how it goes. Okay, so this was a project that's been in the works for about 7 years. I would pick it up and set it down, and I was inspired by kind of the golden age of Hackaday and the kind of projects you come across there. A lot of software, a lot of hardware, a lot of things that you've never seen before. In particular, one guy, Danny Rosen, was making unconventional mirrors back in the days of like Xbox Connect, and like taking a picture of what's in front of it and then representing a mirror with like wooden blocks or feathers or something to show what was in front of it. Someone else had an e-ink display that was displaying movies a frame at a time. So instead of 24 frames per second, he was doing 24 frames per hour. So it would take a day or two to make an entire movie. Both of those things like kind of playing with the scale of like a physical representation on display and also the time. I was also inspired by an industrial robot. You've maybe seen this art installation where there's an industrial robot in the middle with a squeegee on an arm and slowly leaking hydraulic fluid back in before it dies, maintaining itself. So the idea of some kind of inefficient and toiling robot where everything is like out in front of you, nothing's hidden, there's nothing secret here, it's all right in front of you. Then I realized when I was tinkering with this idea that if you make it 25 by 40, that's 1,000 pixels, and we could call that a kilopixel. And I noticed that kilopx.com was available, which is a 6-letter domain name. And so I bought that, and that locked in the basic parameters of the project. It had to have 1,000 pixels. It had to be called a kilopixel. So this was truly like domain name driven development, basically. From that point, my course was set. So at the time, some friends of mine were starting Shift Coffee Shop downtown on Graham Avenue. And I'm a woodworker, like I mentioned, so they recruited me to build some of the cabinetry, the bakery cabinet there, some of the like the pews that you can sit in. I helped them with that. And so I was really thinking about this community they were trying to build. And I was thinking about this display and how it could live in that space and be some kind of like ambient app that you can control. So I was thinking about like an iPad in the space where you can manipulate it somehow. And then I thought about a web app where you could scan a QR code and control it, and that's where I landed. And that also kind of drove this direction of like people collaborating with this display here. Tonight you've seen it just drawing on its own. And it is doing what I need it to do. That's great. I thought it skipped a row, but that's as designed. The idea of people collaborating with it and like taking forever to get around to it. So that drove the course of it. I knew I needed 1,000, and 1,000 is an interesting number because it is both a lot and it is not a lot. So in the context of like your phone display, 1,000 is nothing, but in the context of physical pixels, it is a lot of things. And so that was a really interesting constraint. Basically, this is out of my pocket. I'm not making any money off this thing. It's just been a money pit. And like 1,000 of any pixel is a lot of money. If you can make this pixel for $1, this display costs $1,000 in pixels. If you can make it for 30 cents, it's still $300 in pixels. And so you have to get really creative with what you even make the pixel out of. That immediately rules out anything where you have to buy 1,000 of them, like a motor for every pixel, or even like one of those flip displays that you would see in a train station. If you need 1,000 of those are really expensive. That's like a $20,000 display. Not in my hobby budget. So I tried to focus on making it an N of 1 instead of an N of 1,000. I landed on this gantry idea of one thing manipulating the pixels. I was even looking at like power constraints. If I did 1,000 illuminated pixels, so you can get addressable LEDs. I could tell individual LEDs to turn on. The power consumption of those, you think of LEDs as like free electrically, like 50 milliamps, but 50 milliamps times 1,000 is 50 amps. And so you have to do like, you have to figure out how to power 50 amps. So then you're probably running a few things. You can't run that whole thing in series. You have to do parallel. So 1,000 of something is like just enough to cause problems and force you to have to do it a different way. So I found the constraint of that to be really interesting to just chew on. This is one of those projects where you like pick it up and you think about it and you try something. And then you realize, well, that's not going to work. I have to try something else. So I landed on this gantry. This is basically a plotter. It's basically a 3D printer or a CNC machine. It has 3 stepper motors for the X, the Y, and then the actuator here. These are all component, like off-the-shelf parts. And then it has this off-the-shelf CNC controller here next to a Raspberry Pi. So this Raspberry Pi is running a Python script, and it is communicating over serial, over USB here, to the CNC controller. And it's sending it G-code, which is what your 3D printer uses. It's what a CNC mill uses. It's what a plotter uses. You had a question?
Yeah. So I see the one rail. Is there another rail behind it?
No.
Oh,
All
really?
you see is right in front. It's just
Oh.
plywood on the back. Yep. Yeah, feel free to inspect this thing afterwards. Get up and see what it's up to. So the G code is a really interesting language. You can write it by hand. It's a series of commands where it's like G and then a couple numbers, and then you give it a parameter. So like go on the x-axis 100 millimeters or something like that. And so the Python script runs in a loop, and it generates G code that tells this thing where it wants it to move these motors. And so I can tell it, like, go to this particular location. It's a very restrictive language, again, with constraints. It's very powerful in very specific ways, but you can't get super creative with it, I've found. You really have to play in the rules. The flavor I was using is called GRBL, which is an open source thing that's used for a lot of like DIY laser engravers, that sort of thing. Lots of hardware to mix and match. Like you're basically picking from this world that's already built from you and then playing in that playground. When it first starts, it does a homing cycle. So there are 3 limit switches on this, one for each motor. And we'll probably see it, if you see it stop drawing and go back to the top left corner, that's the homing cycle. And that establishes the 0 point from that point on. So it knows when I hit this switch and this switch and this switch, I'm at 0. And then every move after that is relative. So if it needs to go to the right, it knows I'm right here. I add this many steps and I'll get there. So that homing cycle is really important. And if you lose a step, like it thinks it moved but it didn't, or it moved and it doesn't think it moved, then you are off by that amount. And so you can look at the amount of tolerance I have here. It's probably about 2 millimeters in the x-axis. It's a bit more in the y-axis. I did everything I could to keep those tolerances as large as possible, but if you lose steps, that's a challenge. So I was often fighting with losing steps and how fast can it go without losing a step? Or there's a joint right here because this extrusion is not long enough. How do I make sure that it is a nice smooth joint and doesn't lose a step when it goes over that 1,000 times a day? You had a question?
Is this Vanna?
I don't know that word.
Vanna White.
Oh, no.
She's been replaced. No, is it, so watching what you were...
She is irreplaceable, for the record.
Watching what you were just doing, fiddling around down there in the corner, is it just flipping?
It is. So these are cubes, and they are strung on a wire. So I have 40 wires that go vertically to maintain that, and then they're free to move in one dimension. And then that also forces my grid alignment, which I'll touch on later. That was really important to do. Yes, sir?
Is there a sensor that knows
There
like
is
the
a
state
sensor.
current pixels in? 'Cause
I
noticed
forgot to
that-
put that in my talk. There is a sensor right here. It
Yeah,
has an LED, an infrared LED, and then basically another LED that's just receiving, wired in reverse. And then I have that tuned with this potentiometer. That will just tell me if it's on or off. And so when it arrives at a pixel, it does a sanity check to say, I was told this should be on, but it looks like it's on already, so I'm going to skip it. Or I tried to turn it, but it didn't change state, so I probably crashed, and I am going to back out if I can and home, just in case. I ran this thing unattended at shift for weeks at a time, and it would do approximately 7,000 pixel changes per day. And so even if your error rate is really low, you are going to get errors. And so I had to put a lot of effort to avoid having to go pay $8 a day in coffee and fix my machine at shift every day. I had to build a lot of fault tolerance into it, which was really interesting for a software guy to try to figure out basically physical, mechanical engineering. So
I was gonna say, yeah, for being in a public place and stuff like that, I was thinking about somebody walking up and just being like,
yes, sir. Yeah. So in fact, I thought about that. I was thinking about my children, but yes, the general public too. It would be so satisfying to just wipe your hand across this thing. I actually built in a mode that doesn't try to turn the pixel. It just goes to every location and it reads the state and reports it back to the server. So it knows, again, like the homing cycle and having a relative starting point, it also needs to know what the current state is so it knows what it has to change.
And that's why it moves like 4 times every time when it's a pixel.
It moves, once to read it, and then it does kind of a slide in. You won't believe how much time I spent trying to get it to turn a pixel just right. And side note, the thing that's poking the pixel is actually a glue stick, and I've replaced about a dozen of them over the course of it. They make it about 100,000 pixels before they start getting jammed up and things go wrong. So that's a disposable wear part. I was very pleased with how long it went. So the pixels, again, back to cost constraints, I had to find something that was cheap. I was very interested in ping pong balls. That was my first concept, to have 40 by 25. It would have been larger if I did that. Those are 40 millimeters. But they are surprisingly expensive. You would think ping pong balls would be like $1,000. How expensive can that be? Well, people care a lot about their ping pong balls, and they care about how they behave. So even the cheap ones are not that cheap, and they are not that consistent in size. And if you think about standing on a pop bottle, it won't compress, right? But as soon as you crack it open, it compresses easily. Same thing is true of the ping pong ball. If you melt a couple holes in it, so you can put a wire through it so that it spins, suddenly it is very weak. And the spray paint that you put on it to make it black on one side and white on the other will just flake off and wear off. So I could never get that to work. Couldn't beat that. I mentioned LEDs before. I thought about putting LEDs behind like a half sphere of like a ping pong ball shape again. But I ran into the electrical constraints of that. And frankly, it just felt too easy. Like part of the point of this thing is it's not a digital display. It's hard to change it. And if all I need to do is like put a little current on an LED, okay, that's not as motivating. It doesn't have the struggle to it. I tried wooden balls. I found they were also an inconsistent size. They're heavy. They're hard to paint. Spheres are hard to paint in general. I tried 3D printing spheres. I had an Ender 3 3D printer at the time, which was not up for the task. And spheres, like the dome, doesn't print that well. The last couple layers on a dome doesn't turn out great. I would probably try that again with my current 3D printing setup. Maybe not a sphere, but I rejected that and never looked back. I tried styrofoam balls, which are super cheap, super light, nice and bright, but when you spray paint them, they melt. So you cannot use styrofoam. Also, can't paint. I tried acrylic paints, hard to paint. Again, everything's hard to paint if it's round. One idea I really liked, and I chased this for a while, was illuminated push switches. A switch where you push it and it turns on, and you push it again, right? That'd be pretty satisfying with the little clicky thing. And I have like 50 of them at my house. If you have any great ideas for what to do with 50 illuminated push switches. Again, hard to find for less than like 30 cents a piece, maybe. I was like trolling the bottom of AliExpress and trying to find the cheapest Chinese like 1,000 pixel setup I could find. I was concerned about power in that, and it felt too easy, like the illuminated one. Like, yes, there would be something actually pushing it, which would feel better, but it still felt a little bit too close to like a digital display that we have already. So I eventually landed, after a few others I haven't mentioned yet, on these wooden cubes. This is something I can make. I have a full wood shop. I can make cubes in mass in precise dimensions. It still takes forever. If it takes like 6 operations to make this, however long it takes, 20 seconds, a minute per pixel, that's still 1,000 minutes of making pixels in your garage, like 30 minutes at a time. But I batched as many things as I could. The cube is really interesting because it has 4 sides, of course. So 2 of them are black, 2 of them are white in this. I could actually make this a 4-color display if I really wanted to, but I haven't felt the pull. And then I cut a small notch on the bottom, which lines up with a little shelf here to somewhat index it. So it turns and it kind of settles a little bit. That didn't work nearly as well as I wanted. And I thought about putting a spring on top of each one to really force it into that. But guess what's expensive? Springs times 1,000 are expensive. I don't know why they're expensive. I would have thought you could get a bag of springs for like $10, but you can't. So landed on wooden cubes. I already mentioned the tolerances, making this grid. I didn't intend to have it controlled in 2 dimensions, but I found that even a little bit of error, if this pixel is off by 0.5 millimeter compared to its neighbor, and that's not a lot of error, 0.5 millimeter times 40 is 20 millimeters over the whole thing. And so like it was kind of wavy without something to control it in both X and Y dimensions. I definitely struggled with the tolerances, trying to figure out like just how close can I make these without them crashing into each other. That's a challenge. I fought that for a while, but landed at the tightest possible form. So tech stack. This thing is a physical display here. There are 2 components of it. There's a web app, and then there's a controller, tech stack. The web app, I mentioned I wanted a shared user interface, and so that made a lot of sense. I wanted to use some kind of WebSockets so that it could be like nearly real time if you and I were sitting in the coffee shop at the same time. You could see my changes at the same time. So I built the backend in Node and Socket.io at the time. I rebuilt it a couple times kind of as like a bike shedding project for a while. I wasn't sure if I'd actually ship this, but it was fun to tinker with. And then I landed on PHP and Laravel with a Vue.js front end, which is basically what I use for my day job, and so I was very quick in it. Still using WebSockets. And then this is basically the web app and the API that this thing talks to. So you can think about this as totally separate. Like you could give me an API with 2 endpoints and this would display whatever you tell me, right? That's totally separate. So I got to control what shows up on the display and I got to control how the display is built effectively. This thing, this Raspberry Pi in the Python script, has no idea if this pixel's on or off. It just knows, hey API, what pixel do you want me to go to next? And it will tell it, I want you to go to this location. I want it to be this state, either on or off, and I want you to poke it or not. And then go there and tell me what happened. So after it pokes it, it will say, okay, this coordinate here, 40 by 40, is now on. And so that allows me to do that recovery mode I mentioned, where it just reads the state. It also allows me, I just realized it's redrawing my progress bar. Okay, my talk has to be faster. I adjusted it taller so it would take longer, and then I sent the wrong one. Okay, so see, I had a template to do this amount of talk, and then I shaved it off by about 10% accidentally. All right, we gotta pick it up. Here we go. You know, it's probably taking longer because it's changing more pixels. This is perfect. Okay.
Thank you for answering the question I did.
Why it was doing that? Yeah.
Nobody was gonna
Well,
say anything.
to jump ahead a little bit, this thing draws 1 picture at a time, and so I sequenced 2 pictures, one that had 0 progress bar here, and then I sent it a second one with the progress bar filled. But yesterday I was tinkering with how long I needed my talk to run and how long it would take to draw that, and I had this guy in the queue from when it was a little too fast. But I think since it has to redraw this line, it's going to be a wash. Okay.
I have more questions.
I've got a whole section of Q&A. I can't wait. So the web app, again, has a mode like it does the basic things you'd expect. You can control the pixel, you can draw on it, you can tell this thing what you want it to draw. But but that same web app has a mechanism where it ticks every second. So every single second it checks what mode am I in, and that mode is going to determine what should we draw on this. So I created a bunch of modes. My friend helped me build like a programmatic maze that will make the entire display black and then draw a maze steadily over the whole thing. Random checkerboard patterns and diamond patterns, and it'll decay the entire display 1 pixel at a time. These are all like algorithms that will run to determine what should be shown next on it. There is one mode, maybe my personal favorite, is a clock, where it tries to draw the current time as a digital clock, but it really struggles to draw the ones place. It's in its homing cycle right now, by the way. It takes it about a minute or two to draw the ones place, and so it can be a little behind. It's always working on displaying it. It can keep up. And then I'll get ahead to a submission queue and a submission replay mode that I did as well. Now the controller itself, I touched on it a little bit. So Raspberry Pi, not even the nice one. This is the Raspberry Pi 3B. It's like a $40 computer. That off-the-shelf CNC controller, this is the same one. This particular one I think was like 35 bucks. It has 3 different actual stepper motor drivers that provide the current to the right coil of the stepper motor to make it turn a predictable way. If you're not familiar, a stepper motor is something where you can give it a pulse, like you'd send it a square wave signal, and depending on the characteristics of that, it will move the motor in very predictable directions and distances. So in this case, I think when you give it a pulse, it moves like 2 degrees. So that, depending on your pulley setup and your gear setup, whatever your ratios are, is probably like fractions of a millimeter. So you get a lot of precision that way. This thing can be used for like a CNC router or a laser engraver. It's just a real commodity part. And then the Python script is just running in a loop. Like I mentioned, it just reaches out to that API and says, what do you want me to do next, boss? And then if it has something to do, it'll go do it. Otherwise, it parks in the corner and just hangs out for a while. And then it reports back to the server, says, here's what I changed, what do you want me to do next? It just loops and loops and loops. The only break it takes is if something goes wrong, or if it has done, I think, 100 pixels, then it goes through a homing cycle. Again, trying to be fault tolerant. So I designed this thing for Shift. And it had been about 5 years, and I hadn't shipped it. And I was talking to some friends on the internet about this idea, and they were excited about it, and we were talking about what you could do with it. So I decided to, that shouldn't have been homing when it did. I wonder what happened.
Right as you said, a fault.
It gave me a fault. Perfect.
It must have been.
It's done that. I know it's 4 times now.
Google is listening.
Yeah, this thing doesn't like to be moved, by the way. When I moved it to Shift, it took a couple weeks before it was really dialed in. So we'll see how it handles the rest of the progress bar here.
It's your fault again.
Okay. So I decided I wanted to put this on the internet instead of doing it in person, at least for the first version of it. So I was trying to figure out, like, this idea of 2 or 3 people sitting in a coffee shop doesn't scale up. If it got popular on the internet, like, that would be a mess, right? You'd have people fighting over control of it. So I needed to figure out a system where, if it did get popular, that people would actually be able to do something interesting with it. So some recent inspiration, Our Place on Reddit, if you haven't seen it, is like, I think 1 million pixels. Everyone got like 1 pixel per minute or something, some very specific constraints, and it turned into people like defining bits of territory for their fandom or their football club or whatever it is. Very interesting social experiment, but it had to deal with like way too many people trying to control way too few pixels. More recently, a guy named Nolan did 1 million checkboxes. So everyone was sharing the same field of 1 million checkboxes, kind of similar constraints, not quite at the scale of Our Place, but similar problems. And Twitch plays Pokemon. If you saw that, people were controlling Pokemon through the Twitch chat. Again, people doing interesting things within the constraints. So I didn't hit those levels of success, surely, but those were the kind of inspirations for me. Like, how do you put something out there that could handle like 0 to 1 people, or it could handle too many people, whatever that number is. So I talked with a bunch of friends who have done some game design and that kind of thing. We talked about like the live drawing idea. I rejected that straight out because I think if you had more than a few people trying to draw something within these constraints, it would just not really draw anything interesting. It would just be nothing. I thought about territory control games where you'd like get put in 2 buckets, either the on team or the off team, and you're trying to claim as much of the board. This has always kind of reminded me of Go, honestly, so the idea of like controlling portions of the board was interesting. Or drawing challenges where like one team has the left half of the board, one has the right half, and you're like collaborating on one image. One idea I still want to do is playing Snake. This is more like the Twitch plays Pokemon, but like slow that way down, see if you could play Snake. And then I was also concerned about like abuse and spam and bots and trolls and how many votes am I going to get, and are people going to vote stuff? Are they going to put like distasteful stuff on it? All those concerns, like the idea of putting something on the internet and then live streaming it and letting people control the thing that's on the live stream is a bad idea on its face. So I was thinking a lot about that. The final decision I came to is the mode that it's in right now, which is you get 1,000 pixels, you get the display for as long as it takes to draw those 1,000 pixels, and then immediately it's the next person's turn. So you had to submit these 1,000 pixel arts, which it turns out is very difficult to make a interesting pixel art in 1,000 pixels. It's both not enough and too many pixels at the same time. And then people could vote on them. So we had people like sharing their designs and then voting to get theirs drawn next. So there was a queue. The top of the queue would be drawn next. And as soon as that one finished, right to the top of the queue. What's drawn next? So I had some fun with the voting mechanisms because I didn't want it to take like 4 days for your thing to be drawn. I wanted you to be able to push it up if it was a really good submission. So I had some ways of going head to head between 2 submissions to say like, hey, do you like this one more or do you like that one more? If you like that one more, and it's the underdog, it's going to get a whole bunch of points and shoot it up the list, basically. So it worked pretty well. I got a lot of interesting submissions, and generally they were at the top of the queue. So I wanted this to go viral. If I was going to make it and go through all this effort, I wanted it to be popular. I wanted people to experience it, not for the like popularity to me specifically, but the like edification of I invested I don't know how many hours in this thing at this point. I would like people to enjoy it and do something with it, and I wanted it to be bigger than me once it got out there. So I figured out a live streaming setup. I had a camera mounted right here, so you'd have a close-up of it, the mechanism, so you could immediately see here's what's happening. And then I had a wide view of the whole display. And I set that up in my office. I've never live streamed before, this is all new to me. Figured out OBS cam or whatever it is, OBS, not OSB. That's the hardware product. And got that streaming. Figured out Twitch or YouTube or whatever what works best. And then I wrote up a long blog post and designed it for Hacker News because I felt like Hacker News would be like the kernel, and everything could grow from there. If it worked there, it would probably get popular. So it did. It went to the #1 spot on Hacker News for 24 hours, which was a crazy experience. That's happens a few times a year on Hacker News, but it's pretty unheard of. And then it got picked up by the old internet, which is what I found very interesting. So like Hotkey.org, Waxy, Tom's Hardware, Boing Boing, and then Hackaday picked up my project that was inspired by Hackaday so long ago. And it went to the point that my family was finding out about it, not from me, but like from the internet, surfacing it to them, which was very satisfying. And I would have been happy with like 1,000 people or something like that, but I got 200,000 people read my blog post and then went to my website and controlled this thing as well, which was far beyond, it felt like monopoly money, frankly, to have that many people playing with it. And I got 11 days of submissions to draw. So I ended up live streaming this thing for 11 days. If I had live streamed it for like 2, that would have felt like a huge success. But I knew from the get-go that like the fun of live streaming and having something popular on the internet like the curve of return on that would plummet really fast from having to like babysit the thing and keep it on the internet for 11 days. So once the submissions started to dry up, then I started to plan, how do I exit this? So once it hit 200,000 people, or 200,000 pixels changed, excuse me, I shut down the live stream and put up a couple final messages and closed out the project. And then I just retired and I relaxed with it. Like I chilled for once on my Kilopixel. I don't know how my family has survived me talking about the Kilopixel for as long as it has. So that was really rewarding, and I have this much talk left. That was really rewarding to get it out there and having people like respond, the validation of like, okay, this was worth the effort, or this was an idea that's more interesting than just what has been tickling my brain for the last 6 years. But I really still like the in-person idea. So after it hung in my webcam background for a while, like in my Zoom background, I pitched it to Shift again. Here it's been like 5 or 6 years at this point, and they were glad to welcome this thing to Shift, which is why I'm here, thanks to Dan seeing it at Shift, bringing it back to kind of the original roots of the story. So I put it there with 450,000 pixel changes back in October or so, and it hung there until Saturday when I took it down in preparation for this talk. Where it has gone 1.3 million pixels at this point, which is bananas. The fact that like this little limit switch has survived and these motors, and like with not a lot of intervention, is pretty lucky, honestly.
Don't want to hear it.
Exactly. Now it's gonna fail. See, it's gonna go home. So.
Yeah, let me show you.
So at Shift, I put it back to the original concept of like anyone can draw on it and do whatever you want to it. But an interesting thing I've learned is that people like to observe something like this more than people like to manipulate, if that makes sense. And it's a little paralyzing to say, I don't know what I should put on this thing. So I've been monitoring this from home for months now, and like anytime I see some evidence of someone like drawing on it, even if it's a kid drawing 6'7" on this thing, I'm like, yeah, someone's using it. So it's turned out that the ambient modes were much more interesting to people. Like seeing people walk up to this thing like, what is this? And inspecting it has been really interesting, but it typically ends there, like figuring out what it's doing, what it's drawing. I found that people don't really contribute as much as they watch things that other people build. So one of the modes that I've been running is a replay mode where I took like 30 of the best submissions from that public phase and it just randomly redraws them. So it's displaying interesting art ambiently, but it doesn't require intervention like that. And I found that people like love whimsical, ridiculous, unnecessary things like this. There's something appealing to watching something like you've never seen something like this before, and why would you do this? And then when you hear how long it took and how much of my life it consumed to make it, it just kind of reinforces how ridiculous it is. And then I learned that about myself, that I really enjoy building ridiculous things and sharing them with the world, and like chasing that is really, really interesting to me. So that is my story, and I have 3 pixels to spare, but I would be happy to answer any questions forever. So any questions you have, let's get into it.